All right, so the next thing I'm going to look at is what if we have a function that is a sum of two other functions? How can we find the derivative of that? So again, I'm going to just use the definition of a derivative. All right, so I have a function h of x, so h prime of x is equal to the limit as h goes to 0. Now this is a different h. We got one h that's the name of the function, and then we have the h, which is the interval width. So don't get confused with that by that. But all right, so we're gonna do h of x plus h, right? So I'm just gonna replace x with x plus h. So I end up with f of x plus h plus g of x plus h. And then I'm going to subtract h of x, which is f of x plus g of x. Okay. And then that's all over h. Okay. All right. So now let's do some work on this. We look at the limit as h goes to 0. Now, I can rearrange I can distribute this negative, right? This subtraction. I can make this a minus f of x and a minus g of x. And then I can rearrange the terms in the numerator, right? So I'm going to rearrange this as f of x plus h minus f of x, and then plus g of x plus h minus g of x. Okay, so all I did was distribute the negative and then combine, put the g terms, the f and g terms together. And all of that is over h. Okay, so now I could break up that numerator. I could write this as the limit as h goes to 0. I can actually write this as f of x plus h minus f of x all over h plus g of x plus h minus g of x all over h, right? Just taking the first two terms divided by h and taking the last two terms divided by h. And you can see what's happening here, right? It's starting to look like a lot like the derivative, right? Now, we haven't really gotten into all of the nitty-gritties of properties of limits, but I'm going to tell you that I can actually, this is equal to the limit of f of x plus h minus f of x all over h plus the limit as h approaches 0 of g of x plus h minus g of x all over h. And now you can see that this is just f prime of x plus g prime of x. All right. So when we take the derivative of a sum, we get the sum of the derivatives. All right, which is a nice result, kind of what you might expect. But you have to be careful because sometimes things don't turn out the way you expect. So, but now we've proved that it works. So we have some new rules, and this actually works for subtraction as well. I just didn't show subtraction, but we could do the same thing for the difference of two functions. So it turns out that if you take the derivative of a constant multiple of a function, that's equal to the constant multiple of the derivative, and the derivative of sum is the sum of the derivatives, and the derivative of a difference of function is the difference of the derivatives. So which is nice. Okay, so now we have some new rules, and that we can combine these new rules with the power rule that we learned before to take derivatives of polynomial functions, which have a sum of power functions in them, constant multiples of the sum of power functions. All right, so that's what we're going to do next in the last examples. We're going to look at how we can apply these rules to polynomials.